A modern blast furnace plant uses tons of raw materials to produce its daily output of iron. The preparation and the handling of these enormous quantities are just as important as the actual smelting in the business of making iron. The raw materials will be listed and dealt with one by one. First, the ore from which iron is extracted. Next, coke, the material which provides the heat for smelting. Then limestone to make a fluid slag. And last, air for the blast to burn the coke. About half the iron in Britain is made from imported ore. The rest is from British ore, often produced locally. It is quarried or mined and loaded straight into wagons for transport to the iron works. When on a tour of an iron works, this is how one first meets the chief raw materials. It is not fit to go into the blast furnace as it is. Many of the pieces are too big to be smelted efficiently, and an iron worker knows there is bound to be a lot of dust and fines which would choke the furnace and lead to uneven working. What is needed is a uniform charge or burden with lumps of about this size. The first step is to send the ore to the crushing plant, which will break up the bigger pieces. The crushing is usually done in two stages. This is the first stage, the primary crusher. Wagon loads of ore are tipped in, and all the larger lumps are broken up into pieces less than 8 inches in size. The ore is passed between two large rollers driven by very powerful electric motors. They are shown in diagram, as of course they have to be enclosed in the actual machine. The ore is then taken by conveyor to the secondary crushers. These break up the ore into still smaller pieces, so that when it emerges finally, none of the lumps are more than about 3 inches across. Notice that there are still many smaller pieces, so the next step is to send the ore to the screening plant, where the various sizes are separated from one another. The screening is done in shaking frames like big sieves. There are two, one above the other, the lower with a finer mesh. The top screen takes out the biggest lumps. The lower screen, with a finer mesh, takes out the smaller lumps, and the rest passes through. In the left-hand conveyor, the lumps are ready for the blast furnace and go to the ore bed. There still remains the dust and small chips which have passed through all the meshes. These fines are perfectly good ore, but they must be built up into manageable lumps before they are used. This is done in this plant by a process known as sintering. The fines are mixed with a little coke dust and passed on a moving belt under a hot gas flame which sets the coke alight on the surface. As the belt moves along, air is drawn through it by fans, and fire passes through the mixture from top to bottom. The coke burns away, and the heat produced fuses the ore dust together. At the far end of the belt, it is tipped off in clinker-like lumps. Sintering is an important part of the ore treatment. Sometimes more than 1/3 of the ore is fed to the blast furnace as sinter. There still remains one thing to be done. That is to blend the ore. Batches of ore differ in composition, and the blast furnace will work more regularly if this is even out. A traveling machine is made to spread the ore out on one of the ore beds. The principle used can be shown on a tabletop with sand. The machine spreads out the ore in a long heap. The next batch of ore goes on top, and so on, as many times as are needed to make up the pile. Now, if a slice is cut, it will contain some of all the different kinds of ore. So, if the heap is cut crossways, there will be a blend of all the different grades. Of course, it is a different matter when one deals with heaps containing several thousand tons, but that is virtually what this machine, called a reclaimer, is doing. A big steel-toothed rake moves to and fro across the heap, working the ore down to the bottom. There, an endless belt carries the blended ore to a final conveyor which takes it to the storage bunkers. Preparing the ore is quite a complicated process. A diagram will make it quite clear. The ore first goes to the primary crusher, and then to the secondary crushers. These break the lumps into pieces. Next, the ore is screened to separate the lumps into different sizes. The fines go to the sinter plant, and the rest to the ore beds. Finally, the ore and sinter are fed to the blast furnace. The whole process is continuous, and so is able to handle the huge quantities efficiently. Coal is chiefly made up of carbon, the element needed in the smelting process. But coal itself is not very strong and would not stand up to the immense weight of the burden in a modern blast furnace. Also, it contains certain other valuable substances which might be lost if the coal was used directly in the furnace. However, if coal is made white hot in a chamber closed so that air cannot get in and make the coal burn, these other substances are driven off as gases and vapor. What remains when it is cooled is coke, almost all carbon and strong enough to stand great pressure. This process is done in the coking plant in batteries of ovens, often more than 100 in a line. Coal is fed into the tops of the oven, often in the form of slag from a hopper cart, and kept at red heat for about 18 hours. During this time, the gas and vapors are removed. They are not allowed to go to waste. The gas is first taken to a byproduct plant where various chemicals are recovered from it. Finally, the clean gas is used for many important heating jobs in the steel works. These open hearth furnaces, for instance. When the coal has been heated for the correct length of time, the airtight doors of the oven are removed, and a giant ram pushes the whole charge into a waiting car. The hot coke would burn away into the air if it were left to itself, so the car immediately takes it to the quenching tower. Here it is sprayed with water to cool it down, producing clouds of steam. Finally, the car tips the quenched coke onto a walk. From here, it is allowed to pass a little at a time onto a conveyor which carries it to a screening station and then to the storage bins at a blast furnace. In these bins are supplies of all the solid raw materials needed for making iron. Some bins will contain home ore, some will contain foreign ore, richer in iron. Generally, plants use either home or foreign ore, but some use a mixture of both. Some bins will contain coke, and some will contain limestone, the third raw material used in iron making. This is quarried and broken down into a convenient size in much the same way as the iron ore itself. From these bins are taken the weighed quantities of each material, which are carried up the skipway to the top of the blast furnace. The skips fly up and down, continually carrying the correct amounts of iron ore, limestone, and coke to maintain the correct burden. The solid raw materials have been described. The air blast remains. When you look through a peephole near the bottom of the blast furnace, you can see the material inside at white heat. One of the purposes of the blast is to generate as much heat as possible. It helps, then, if the air itself is heated first. Beside the furnaces are the hot air blast stoves to do this job. The stoves are heated by blast furnace gas. This burns in a stream of air blown through the stove by a fan at the base. The burning gas travels to the top of the stove, up a hollow flue lined with fire brick known as a combustion chamber. Then it is diverted down the rest of the stove, which is filled with a honeycomb of fire bricks known as checkers. The gas flame is kept burning until the checker bricks have become very hot. Then the gas is cut off, and the cold air blast from the burners is blown through the hot stove in the opposite direction. Thus, it gets heated up before going to the blast furnace. When a stove is hot enough, the operator shuts off the gas burner and opens the cold air valves. He then goes to the stove, which is cooled down, shuts off the cold air blast, turns on the gas burners to heat the stove up again. The inside of the stove is usually hot enough to light the gas as soon as it is turned on. There are always at least 2 stoves, generally 3, to a blast furnace. Here is how it works in the case of 2. Number 1 is heating the blast and in the process cooling down. Number 2 is being heated up, ready to take over as soon as number 1 is too cool. Then, while number 2 is being used to heat the blast, number 1 is being heated up, and so on. Of course, the process in the diagram is speeded up. Normally, each stove serves the furnace for about 30 minutes, and there is no interruption in the hot air for the furnace. This ironworks has 4 blast furnaces. And here are shown the 12 stoves which serve them, 3 for each furnace. You have seen how ore, coke, limestone, and air are prepared and fed to the blast furnace.